So the last unit focuses on what's called discrete mathematics. So discrete mathematics takes the concepts of arithmetic and algebra that you've already learned and puts them into a different context. It applies it to other areas of math. So those of you who are going to college or have ideas of going to college, whether it's 2-year, 4-year, trade school, etc., you may have to take a math class that isn't a algebra class, but it is a class that uses a lot of the arithmetic skills, a lot of the algebra skills that you've learned in high school. One of the branches of discrete mathematics is known as matrices, which, if you have worked with a table, matrices are not that difficult to pick up on. So a matrix is nothing more than a rectangular arrangement of rows and columns. You're essentially looking at tables, except without units or labels on them, they're just numbers. So the number of rows and the number of columns a matrix has, those are known as its dimensions. Known as dimensions. For example, they measure your room. If your room is 10 feet long and 16 feet wide, those are the dimensions of the room. Just like with a matrix, it has dimensions as well. So, dimensions are the number of rows and the number of columns. So, rows are the number of lines you have going left to right. Columns, up and down. Number of rows, number of columns. So for this first example, you have 1, 2, 3 rows, 2 columns. So 3 rows and 2 columns is 3 by 2. And if it asks you for the dimensions, that's all that is. 3 by 2. For the second example, 2 rows, 2 columns, so that's 2 by 2. So notice that the row always goes first, column goes second. Row, then column. So for the third example, 1, 2, 3, 4 rows, 2 columns, 4 by 2. So remember, rows go left to right, columns go up and down. So, just a couple of things to know about dimensions. So a row matrix means it just has one row. So this example here, one row. A column matrix, one column. A square matrix means it has the same number of rows and columns, so it looks like a square. So for the example that's provided, 2 rows, 2 columns, 2 by 2, that's a square matrix. So 1 by 1, 2 by 2, 3 by 3, 4 by 4, those are all square matrices. So, any questions on the vocabulary aspects before we actually do some computation? Not seeing any, not hearing any. So let's continue. So now we're going to actually get into some computation. So the three main ways we do operations with matrices is addition, subtraction, and scalar multiplication. So scalar multiplication is you taking a matrix and multiplying it by a number. So when you add or subtract matrices, you add or subtract the corresponding parts. However, you can only add and subtract if the dimensions are the same. So each matrix has to have the same number of rows, same number of columns. Again, think of a matrix as a table. You can only add two tables if they have the same number of rows and the same number of columns. So for example, this first setup, you have 1, 2, 3 rows, 2 columns. Second one has 1, 2, 3 rows, 2 columns. So you can add these. Since they match, you can add these up. So you would take 3 plus -6, 4 plus -3, 5 plus 4, and so on through the list. You can take the parts and add them together because the dimensions match. So this is okay to add. Any questions on that? So, same rule applies for subtraction. First, make sure that they're the same size. You get 2 rows, 1, 2, 3, 4 columns. So this is a 2x4. This second matrix, 1 row, 1, 2, 3, 4 columns. That's a 1x4. Not the same. So not same dimensions. Cannot subtract. So if you can't subtract them, please do not force it either. Don't get cute. Oh, I'm going to take this top row and subtract it from that thing. No, that's called being cute, and that's wrong. That's not even mathematically correct, so don't do it. If they don't have the same matrix, if they don't have the same dimensions, you cannot add, you cannot subtract. So, any questions before we do a few examples? Okay, the adding and subtracting part is pretty easy, as long as the dimensions match. If you have questions, you gotta ask. Can't read your mind. We're coming down to crunch time here. So let's look at examples 1 and 2. Do 2 adding, then do 2 subtracting. So for example 1, we want us to add these matrices together. Again, we have to check, make sure that they're the same size. So 3 rows, 2 columns. So that's a 3x2. 3 rows, 2 columns. 3x2. So they're both 3x2s. So they're good to go. Both 3x2, so we're good to go. So hopefully Sterling and Mariah are taking these notes. So they can do well on the 2 IXLs that goes with it. So now let's add them up. So we added up part by part. So if you were to take the first matrix and put it on top of the second matrix, whatever it would have been on top of, that's what you add together. So for problem 1, 3 and 0 are in the same spot. So you would add those together. 3 plus 0 is 3. Six plus -1 is 5. -1 plus 6 is 5. -3 plus 0, -3. -5 plus 2, -3. -1 plus 3, 2. That's it. Problem's over. That's all you're doing. Add up the corresponding parts. I'm just writing on underneath what we did in case someone needs to go back and look at the notes later. That's how we ended up. Any questions? Example 1. All right, example 2. Again. So we have our 2 matrices. First, you check to make sure that they work. 2 rows, 3 columns, 2 by 3. 2 rows, 3 columns, 2 by 3. So the dimensions match, so we can go ahead and add. So you have 2 plus 3, which gives you 5. -4 plus 4, 0. 0 plus -1, -1. Same thing to the bottom. -1 plus 7, 3 plus 0, 5 plus -2. That's it, that's all. Problem over. So, questions 1 or 2? All right, then let's do the same thing with subtraction. Subtraction follows the exact same rules. As long as the dimensions are the same, then we can go ahead and subtract. So, 2 rows, 3 columns, 2 by 3. 2 rows, 3 columns, 2 by 3. So we can go ahead and subtract. -5 goes with 6. -5 minus 6, which is -11. 2, -5. 2 minus -5 is 7. Negative 2 minus negative 6 is 4. Any questions on how we got that first row? All right, second row. 4 minus 1 is 3. Negative 2 minus 3 is negative 5. 0 minus negative 3 is 3. Here's your matrix. Taking two tables and adding them together. So we will, in this case, subtract. All right, so example 4. Same concept. 2 rows, 2 columns, 2 by 2. 2 rows, 2 columns, 2 by 2. Since they match, we can subtract. If they didn't match, we cannot subtract. So 3 minus 1. That gives us 2. 4 minus 7. Negative 3. Negative 2 minus negative 8. 6. 0 minus 1. Negative 1. Any questions, 3 or 4? All right, not hearing any, not seeing any, so let's transition on to multiplying by a single number. So when you multiply by a single number, multiply a matrix by a single number, that is known as scalar multiplication. Scalar multiplication. So simply multiply the number outside the matrix times everything inside. Simple as that. So for example 5, you have this matrix multiplied by the number 4. So you're going to take 4 times negative 4, negative 16. 4 times 3, 12. 4 times negative 5, negative 20. Just like that, problem's over. Literally taking everything, multiplying it times 4. Same thing applies to problem 6. You have a matrix, negative 5 sitting outside. So everything gets multiplied times negative 5. So negative 5 times 5, negative 5 times 6, negative 5 times negative 4. It's negative 5 times 4, negative 5 times negative 2, negative 5 times negative 1. So to solve this all out, negative 25, negative 30, positive 20. Remember, negative times negative is positive. negative 20, 10, and 5. Yeah, I'm not pulling your leg here. I'm not setting you up some blood mission. This is literally what you're doing. So it is fairly simple if you pay attention to what you're doing. Any questions on 5 or 6? All right, and the last part is, well, what if you have more than one operation? So more than one operation simply means order of operations. That's nothing new for us. Remember order of operations, that's parentheses, exponents, multiply or divide from left to right, add or subtract from left to right. So since we're only really dealing with multiplication, adding and subtracting, you won't have to worry about the other 3. So for example, 7, you have subtraction and subtraction. First, make sure everything is the same, or the same dimensions. So 2 rows, 2 columns, 2 rows, 2 columns, 2 rows, 2 columns. So everything's the same size. If it's not the same size, you can't add, subtract, or anything along those lines. But now you just work the problem like you would the order of operations. Do it 2 at a time, going from left to right. So we work the first 2 matrices. 5 minus negative 6 is 11. 3 minus 0, 3. 5 minus 1, 4. 1 minus negative 4, positive 5. You can bring the other part down. Then you do it again with the other piece. 11 minus 5, 6. 3 minus 4 is negative 1. 4 minus negative 2 is 6. 5 minus negative 6, 11. So there's our matrix. Any questions, example 7? And it's not an overly difficult problem. And if you really think about it, you've done harder stuff in this class before. All right, let's finish it off with example 8. So again, order of operations still applies. So we have a matrix plus 5 times another matrix. So this 5 is multiplying times that matrix. So you have to multiply it in first. Multiply the 5 into the second matrix. So the first one comes down. We're not ready for it yet. So negative 20, 30, 5, 5, negative 20, negative 5. So multiplication still comes first. Then we add everything together. Negative 1 plus negative 20, negative 21. 1 plus 30, 31. 6 plus 5, 11. Negative 4 plus 5, 1. 0 plus negative 20, negative 20. 0 plus negative 5, negative 5. Just like that, problem done. And doing an order of operations, not difficult at all. You just have to know the order of operations and be willing to apply it the right way. Any questions on 7 or 8? We get ready to close up shop in a second. We were done with 11.1. That wasn't that bad. Yeah, for some of you, don't forget. For some of you, math does come pretty easy to you. You just have to do the work. I can't do nothing about that part, though. You have to do the work. So, there.